So the question is, from the following data, find f of 14.5 and f of 16 using Gauss forward and backward interpolation method respectively. The data are x of is 0, 0, 5, 0.0875, 10, 1.7, 15, 0.364, 20, 0.4663, 25, 0.2679, 30, 0.5774. So this one is the data. So please note this value. In given question, this is actually roll number divided by 10. So I took roll number as 17. So 17 by 10 is 1.7. Okay. So now here, if you are going through this x value, this one is a finite difference data. So this one is a finite difference data. So we have to use the finite difference extrapolation. So here we are asked to use Gauss forward method for 16 and backward difference for 14.5. So not respectively, a small mistake is there. We have to use Gauss forward for f of 16 and we have to use Gauss backward for 14.5. Okay. So now, if you are finding f of 16, what we need? For both f of 16 and f of 14.5, we need a central difference table. So that we are going to construct. So this one is a central difference table. This is x of, the data is 0, 0, 5.0875, 10, 1.7, 15, 0.364, 20, 0.4663, 25, 0.2679, 30, 0.5774. So by using this data, the first central difference is determined. So 0.0875 minus 0 is 0.0875. 1.7 minus 0.0875 is 1.6125. This one is the central position. Now 0.364 minus 1.7 is minus 1.336. 0.4663 minus 0.364 is 0.1023. 0.2679 minus 0.4663 is minus 0.1984. 0.5774 minus 0.2679 is 0.3095. So this is first central difference data. So by using this first central difference, we have to find the second central difference. So 1.6125 minus 0.0875 is 1.525 minus 1.336 minus 1.6125 is minus 2.9485. 0.1023 minus 1.336 is plus 1.4384. Minus 0.1984 minus 0.1023 is minus 0.3007. 0.3095 minus 0.1984 is 0.5079. So this one is the second central difference. So by using this second central difference, we have to find the third central difference. So minus 2.9485 minus 1.525 is minus 4.4735. 1.4383 minus 2.9485 is 4.3868. Minus 0.3007 minus 1.4383 is minus 1.739. 0.5079 minus 0.3007 is 0.8086. So this is third central difference. So using this third central difference, we have to find the fourth central difference. So 4.3868 minus 4.4735 is 8.8603. Minus 1.739 minus 4.3868 is minus 6.1258. 0.8086 minus minus 1.739 is 2.5476. So this is fourth center difference. Using this data, we have to find fifth center difference. So minus 6.1258 minus 8.8603 is minus 14.9861. 2.5476 minus 6.1258 is 8.6734. So this is fifth center difference. Using this fifth center difference, we have to find sixth center difference. That is 8.6734 minus 14.9861 is 23.6595. So what we are using for forward difference, we are using first, what is the center data? We have 7 data, 1, 2, 3, 4, 5, 6, 7. So the fourth data is x0. So for forward different, means for Gauss forward, not forward different, this is actually Gauss forward center different. So we need the center data like this one. Then as the odd difference are missing, we have to use the next one. Right. Okay. So we are going to use this data for to find f of 16. We are going to use Gauss forward. So what we have? First one, xp is 16, x0 is 15, h is 5. So p is equal to 16 minus 15 divided by 5, that is equal to 0.2. Now by using Gauss forward center difference formula, yp is equal to y0 plus p into theta y 1 by 2 plus p into p minus 1 divided by 2 factorial into theta square y0 plus p plus 1 into p minus 1 divided by 3 factorial into theta cube y1 by 2 plus p plus 1 into p minus 1 into p minus 2 divided by 4 factorial into theta raised to 4 y0 plus etc. So what is f of 16? That is equal to y0, this is y0 plus p into theta y1 by 2, so this is theta y1 by 2 plus p into p minus 1 divided by 2 factorial into theta square y0, this is theta square y0 plus p plus 1 into p minus 1 divided by 3 factorial into theta raised to 3 y1 by 2, this is theta raised to 3 y1 by 2 plus p plus 1 into p minus 1 into p minus 2 divided by 4 factorial into, this is theta raised to 4 y0, this term, plus p plus 2 into p plus 1 into p minus 1 into p minus 2 divided by 5 factorial into theta raised to 5 y1 by 2, this is theta raised to 5 y1 by 2 plus p plus 2 into p plus 1 into p minus 1 into p minus 2 into p minus 3 divided by 6 factorial into theta raised to 6 y0, this is theta raised to 6 y0. So you see, this is our extrapolation formula. So what is the final each term? So this is 0.364, this is 0.0205, this is minus 0.1151, this is 0.0556, this is minus 0.0882, this is 0.055, and the last term is minus 0.07. So the answer is 0.2218. Means f of 16 is 0.2218. Okay. Now we are going to find f of 14.5. So the same data we have, same central difference. I told you for both Gauss forward and backward interpolation method, the table used is same. The only difference is that Again, this is x0 equal to 15. So we need this central data. Is it okay? But the odd data are missing. So we have to use the previous one. Okay. So please note here xp is equal to 14.5, x0 equal to 15, h equal to 5. So p equal to 14.5 minus 15 divided by 5, that is equal to minus 0.1. So what is Gauss backward formula? Yp is equal to y0 plus p theta y minus 1 by 2 plus p plus 1 into p divided by 2 factorial into theta square y0 plus p plus 1 into p minus 1 divided by 3 factorial into theta cube y minus 1 by 2 plus p plus 2 into p plus 1 into p minus 1 divided by 4 factorial into theta raised to 4 y0 plus p plus 2 into p plus 1 into p minus 1 into p minus 2 divided by 5 factorial into theta raised to 5y minus 1 by 2 plus etc. So by substituting corresponding values, we have yp is equal to y0 is 0.364 minus p into, sorry, this is actually plus into p, right, plus p. So plus p means p is minus 0.1, so plus minus, it will become minus 0.1 into theta y minus 1 by 2, that is minus 1.336 plus p plus 1 into p divided by 2 factorial into theta square y0 plus p plus 1 into p minus 1 divided by 3 factorial into theta raised to 3y minus 1 by 2 plus p plus 2 into p plus 1 into p minus 1 divided by 4 factorial into theta raised to 4y0 plus p plus 2 into p plus 1 into p minus 1 into p minus 2 divided by 5 factorial into theta raised to 5y minus 1 by 2 plus p plus 3 into p plus 2 into p plus 1 into p minus 1 into p minus 2 divided by 6 factorial into theta raised to 6 y0. So this is equal to 0.364 plus this one is plus 0.1336, this one is minus 0.0647, this one is plus 0.0724, this one is minus 0.048, this one is plus 0.0493, this one is minus 0.0376. So the final answer is 0.469. 0.469. Okay. So I am going to show the corresponding calculations. So this one is a central difference table that we shown. This one is Gauss forward method. This is Gauss backward difference. Okay. So you can see that. So now if you are changing this system in order to validate this, if you are substituting 0, this is 0, this final one is 0. If it is 5, that is 0.0875, that is this term. If this is 20, this is 0.4663, that is this data. So corresponding to 16, it is giving 0.2218. Now similarly, this is Gauss backward method. So if it is 30, we have 0.5774, that is this data. Corresponding to 25, it is 0.2679, that is this data, etc. So that one is also correct. So this is corresponding to 14.5, this is 0.469. Okay.